All right, Doozer shop here. Little video. I have a question actually for those with more experience with horizontal boring mills, and I've got the Giddings and Lewis 25T here, and if you don't know Uncle Maxim, check his channel out. I don't know how to get you to it because it's in like Ukrainian or Polish. I think it's, anyways, he's got a 25T over in Ukraine, and he's totally restoring it. So that's helping me with a lot of the pictures inside of what it looks like if I ever have to get into it. But anyhow, question for threading on a horizontal boring mill. The thought occurred to me, and I thought I read about it on the internet or Practical Machinist or something. Let's go and look. I want to show you something right here. So hang with me. All right. So the mighty Giddings and Lewis. Okay. I think this machine was conceived in the 1920s. I believe this is a 1946 model. And unfortunately, sometimes it's more of a shelf, but I have used it multiple times, and it is deluxe to use. It really is nice. But what I was wondering about is this, okay? This is the placard for the feeds, right? And it's B, C, A, D, A, E, A, F, B, C, D, all this stuff. And what that is for the table feeds, it's all this regalia, right? There's two levers, A, B, C, D, no, G, H, I, J, K, L. Right, okay, so forgive the shadows. G, J, H, M, K, L. Okay, so that's the two levers. And my writing is just, this lever is high, low, medium. This lever is high, low, medium. Okay, it's my cheat in different color magic marker. Okay, that's what it is. But nonetheless, so this is the table. Well, this is the table or the spindle, right? Feeds. But anyhow, if you take all this, right? So you know, this is, I hope this is coming up. 25 thousandths HK position. Inches, feeds in inches per rev of spindle. Okay. So for each rev of the spindle, you can get the spindle to move 25 thousandths, or the table, or, you know, spindle of the table, I guess. So those of you who know, a micrometer is 25 thousandths per revolution, right? So it's, you know, 25, 50, 75, and then the next 100. So if you know that 25 threads per inch, no, I'm sorry, a lead of 25 thousandths gives you 40 threads per inch, right? And, you know, 100 thou, right? 100 thou per rev, GK, is, you know, 10 threads per inch, right? And I guess this is rapid feed. This is 250, a quarter inch per revolution is 4 threads per inch. So I worked out in magic marker here, you know, from the rapid feed down to the slow, fine boring, 200 threads per inch. So, if this machine had like a threading tip, a threading tool bit, or a threading insert in a boring bar, you could cut 4 threads per inch, or 6 threads per inch, or 10, or 16, or 24. I don't think you'd ever want to cut 40 or all that baloney. 24 is kind of in between, you know, quarter 20 and quarter 28. There is a quarter 24. You'd never bore nothing that small though. So boring stuff that's big, you'd probably do 4 threads per inch. Absolutely. 6, I think so. Yeah, some lathe spindles are 6. 10 threads per inch. Yeah. On a big diameter, maybe 16 for some kind of a bearing nut. Hell, maybe even 24 for a bearing nut. But these bigger pitches, you could cut. Now what would you do? I mean, I just got my ER adapter in there now, but if you had a boring head, you could stop the head in cut. You take a pass right through, cut your thread, and you got to go deeper. So you could, you know, move the table, you know, stop the machine, right? Stop the machine, pull the clutch lever, you know, or, you know, turn the power off or release the dog. Move the table out of the way. Back up, you know, your bar, right? Why is that stiff? It's just stiff. Back your bar off. Retract your boring head, okay? And reset the table to 0. So what you'd have to do is not disengage it. You'd have to pull it out and then run it reverse, because this lever here, right, that's a forward neutral reverse clutch. So forward neutral reverse. So what you'd have to do is leave everything engaged, like, you know, you're synchronized. Move the table sideways. Oh. No. Well, how would you? You'd almost have to have the boring head, wind the tool back in for clearance, and then reverse it. You couldn't move the table. No, you can't move the table because you can't unclutch anything. Because if you move the table sideways, you can't. So this is the feed clutch. You can't unlock the feed clutch and retract the spindle. You can't, because then you're out of sync. So the only thing you could do if you had a boring head is wind the bar back in, you know, to the middle position, so you're just cutting air, reverse the machine, reset your tool bit to the next depth increment, and run your, you know, machine forward again. You know, have it, you know, cut your threads and, you know, do your thing. Stop. Turn in your tool bit for clearance, and then run the machine clutch in reverse, and then, you know, retract your boring head. So I guess you could do it. I guess that's a way to do it, but you can't unlock the synchronization of anything. You just have to retract your boring bar in your boring head. I think that's the only way to do it. But anyhow, I just wanted to make this video and ask some of you guys with horizontal boring mill experience if this is like a thing, or if I'm crazy, right? I don't think I'd ever do this, but never say never. It's always nice to keep an option in your back pocket. So like I said, I wrote down the threads per inch in magic marker, just kind of haphazardly just to see. But anyhow, let me know what you think. I appreciate the comments and you know, other people's experience with this kind of stuff. So leave me a comment if I'm on the right track with retracting the boring bar and reversing everything, leaving all the power feeds engaged. So anyhow, thanks for watching. This is Doozer's Shop.